I wish you feeling good. I am glad to be with you today in this wonderful conference. Thanks to everyone. My name is Ahmed Salama, Professor of Mathematics and Computer Science, Faculty of Science, Port Said University, Dean of the Higher Institute of Business and Computer Science, Arish, Egypt. And today, I will talk is my presentation about Neurosophic information system for antivirus, an applied study on coronavirus. And with the team for this paper, Muhammad Fazza, Muhammad Yahya, Muhammad Kazim. I hope you will like it. Medical workers deal with a vast amount of information, which has ranging from the one of laboratory tests, clinical and physiological observation. As doctors began a shift in clinical practice from an accidental analysis to relying on the accuracy of their observation to analyzing different evidence and structured algorithms, relying on groups of conceptually update to improve the ability to diagnose diseases or predict or predict patient outcomes. From this standpoint, that study which relies on the use of artificial intelligence and Neutrosophic techniques to identify people with this virus in degrees of certainty and uncertainty. And they exploit this in the medical aspects to provide the greatest amount of time and money. The idea depends on the use of microscope which is connected to the computer and link it to the image matching program. After that, the photograph blood samples as well as samples taken from the mouth and nose, as well as it is possible to photograph the from the inside of the large number of injured and infected people, as well as suspected of infection, and provide a large number of references for this program for each type of those different samples. It is possible to perform this process in 5 minutes, save time and money. Make analysis for the largest possible number of people and provide information in accelerate and documented manner, which is through the Neutrosophic time series, where this rule enables us the basis and analysis of dealing with all data, whether specific or not, that can be taken by time series values. Then we present the linear model for the Nitrisophic time series, and we test of each coefficient based on patient's distribution. The implementation steps require: number one, providing modern computers inside the isolation hospitals with program for matching pictures, processing data, and issuing expectations and recommendations. Number two, provide a special microscope for imaging samples connected to computer, as well as a high quality camera connected to the computer as well. Number three, place blood samples as well as samples taken from the mouth and nose on the microscope. Take pictures and place them on the program. Take number four, take pictures of patient's mouth from the inside beginning of the theory and put them on the program. Use all images for samples and mouth and put them as references for the program, and divide the pictures into patterns, and each reference pattern is different. Number six, determine the different virus patterns from the pictures and put all the data related to the pattern of the health state and development in the case. Number seven, take samples from persons suspected of being infected, as well as those in connect with patients, and provide them with the program. The start of applying this system in hospitals to identify the injured and the saving of time, efforts, and money. The following experiment package and the Neutrosophic information system. 5 stage. The first stage sample collections. The second stage, setting and photographing samples. Third level, putting pictures on the program and processing. Number 4, the fourth, determine the differences of similarities between the different images. Number 5, the principle of Neitrosophic computing. Useful tools, soft implementations of the following of the applications. A Neitrosophic system consists of or contains Neitrosophic data. Neitrosophic system implies or leads to Neitrosophic information, leads to Neitrosophic wisdom decision. What is the Neitrosophic? In 1999 and 2002, Samarnadaki defined the notion of Neitrosophic sets, which is a generalization of fuzz sets and Einsteinistic fuzz sets. In 2015, Salama and Samarnadaki were introduced the Neitrosophic crisp set theory and many applications in computer science information system. In 2014, Salama and Samarnadaki designed and implemented an object-oriented programming to deal with the Neitrosophic data operations. Salama and Promi first introduced the concept of rough Neitrosophic sets handle on complete and indeterminates or information, and studied some operations by using the package of the object-oriented programming. And many applications in computer science. This is the Neitrosophic component. Neitrosophic component consists of three functions: membership functions, indeterminacy, and non-membership function. Thank you for all kind attention. I hope you have liked the topic today.